Hello and welcome once again, ladies and gentlemen, to our virtual classroom. Today we're going to be going over the review for tomorrow's test. So that is going to be the Unit 5 CBA, the Unit 5 CBA review. And so I'm just going to be going over the questions one by one, and hopefully as we go through them, I'm going to try not to give you the answer, but rather teach you or help you think your way through these problems. So what I recommend is that as I go through each one, pause the video, see if you can do it on your own, and then see if your process is the same as my process. Not to say that my process may be the only way of going through it, but especially if you're lost and not really sure what to do, then I recommend that you go through it the way that I did it. Also, I'm going to try to stick to ways that we covered in class, ways that you would probably be able to figure out on your own if you were paying attention or if you were looking at your notes. So here we are beginning with number one. Number one reads, by what factor do the following numbers change each day from the first day to the fifth day? All right, so see if you can do that on your own. Notice that we're seeing, in other words, what is happening each time as you go from day one to day two, from day two to day three, from day three to day four, and what would it be here as we go on to the fifth day? All right, by what factor do the following numbers change each day from the first day to the fifth day? Now, in class, I actually did this incorrectly. Not that I did it incorrectly, but rather I misread the question. That's why it's so important to read the question, because it's asking by what factor. In other words, what am I multiplying each time to get from one number to the next? So for example, how do I get from 6 to 42? Well, if you know your 6's, you know that it's 6 times 7. So that's the factor that I'm looking at. Well, how do I get from 42 to 294? Now, I suspect it's going to be 7 because it's going to be the same factor. So I can do 42 times 7. 42 times 7. Or I could do 294 divided by 42 to see what factor that is going by. So 7 times 2 is 14, 4 times 7 is 28, 29. So again, it's 294. So it seems to me that I am increasing by a factor of 7 each time. So ladies and gentlemen, the answer is simply just 7. 7. All right, let's try the next one. Again, I encourage you to read it, try it on your own, and then you can resume the video and do it with me. It reads, Ms. Adame runs after school on 5 of 7 days this week. 5 of 7 days this week. What percentage of the week did she run? Okay, so again, try it on your own, and then resume the video, see if you can do it. All right, what I notice here is that it's asking here in the question, what percentage? Anytime, ladies and gentlemen, that's asking for a percentage, you know that I'm looking for something over 100. I'm looking for some amount over 100 because a percent is always over 100. So what percentage over 100 is equivalent to the part out of the whole that is given to me? The part that she runs is 5 days out of the 7 days in the week. Part over whole, percent over 100. Ladies and gentlemen, anytime you have this format, you have two ratios that are equivalent, and you're missing one part, you can always cross multiply and divide by the number next to the letter. So I'm going to begin by making an equal sign. I'm going to cross multiply. 100 times 5 is 500. And 7 times x is going to be 7x. So I just cross multiplied. Final step, divide by the number next to the letter, which is x. So I'm going to divide by 7. And whatever I do to one side, I do to the other. So my final answer is going to be whatever 500 divided by 7 is. Now, do note that we need to round to the nearest whole percent. In other words, the nearest whole number that I get here. All right, 7 goes into 50. 7 times 7 is 49. Remainder 1. Bring down the 10. 7 goes into 10. 1 time, remainder of 3. And we bring down a 0. After putting down the decimal, 7 goes into 30. 4 times. And I'm going to stop right there because, again, I'm rounding to the nearest whole percent. So I'm left with 71 and 4/10. 71 and 4/10. And from here, since I'm rounding to the nearest whole percent, I need to see what the 4 makes me do. The 4 makes me stay there. So my final answer is going to be 71. Do not put the percent symbol. It's already there for you. So it's about 71%. She runs 71% of the week. All right, let's do the next one. Let's go for number 3. Again, read it and see if you can do it on your own. See if you can do it on your own. Now, there's 2 right answers on this one. There's 2 right answers on this one. So assuming that you've already read it and done it on your own, what we have here is that here, Mr. Lugo, yours truly, is mixing purple and black Play-Doh for some random reason. Don't ask me why. And all 3 of these tables start off with that ratio, 2 purple for 5 black, 2 purple for 5 black, 2 purple for 5 black. We want to see which of these show a proportional relationship. In other words, you can think of all of these as fractions, 2/5, 4/10, 6/15, and ask yourself, are these equivalent? Are they equivalent? Now, ladies and gentlemen, there's 2 ways of comparing fractions. Number 1, the safest way, in my opinion, is always to cross multiply. 5 times 4 and 10 times 2. If they're equivalent, they're going to give you the same answer. 5 times 4 is 20. 10 times 2 is 20 as well. So yes, these are equivalent. So if these 2 are equivalent, if one of these is also equivalent to this last one, then they're all equivalent to each other. Well, I'm going to use 4/10. So 10 times 6 is 60. 15 times 4 is 60 as well. So yes, these 2 are equivalent, meaning that they're all equivalent with one another. So yes, A is definitely one of the answer choices. Now, another thing you could have done, ladies and gentlemen, is use scale factors, meaning by what factor can I multiply 2 by to get 4? Well, that would be 2 times 2. Now, if these 2 are equivalent, then I should be able to multiply the 5 by the same factor, so times 2, and that should give me the denominator of the next fraction, which is indeed 10. 5 times 2 is 10, 2 times 2 is 4. That works. Let's see here. Can I go from 4 to 6? Not with a whole number. So I'm going to try 2 times what gives me 6? Well, I know that 2 times 3 gives me 6. So 5 times 3 should give me that denominator. Is 5 times 3 equal to 15? It is. So ladies and gentlemen, again, it shows that all of these are equivalent. That is not going to be the case for these 2. So check which of these 2 is also equivalent and which one is not. I'll let you do that on your own because again, there's 2 right answers for this one. Moving on to number 4. Number 4, again, read it and then try to do it on your own. Assuming that you've already tried on your own, this is what I see here, ladies and gentlemen. Mr. Mendoza is mixing 1 head of lettuce for every 3 carrots. We want to know which of these ratios is equivalent to that same ratio. Well, what are the 2 things that we're comparing here? We're comparing lettuce and carrots. And the ratios of lettuce to carrots is 1 to 3. So we have to see which of these ratios. Is it 2/4? Is it 6/18? Is it 3/12? Is it 9/3? Is also equivalent to 1/3. And it says select all that apply, but only one of them is correct. So which of those is the same? Ladies and gentlemen, there's 2 ways of doing it. You can either use cross multiplication or use scale factors between those 2 fractions. Try it on your own. See how well you do there. And again, if I'm going too fast, just rewind it a little bit. Watch it again. Watch it again. It'll make more sense the second time. Let's come here to number 5. Again, try it on your own. And if you feel like you cannot, then follow along with. Table below shows the gallons of gas Mr. Lugo used as he drove over 7 days. Based on the information, how many gallons of gas will Mr. Lugo consume if he drives for 7 hours? So notice that we're comparing hours and gallons. All right, hours and gallons. Now, what is the ratio of hours to gallons? Well, I'm giving 3 different ratios. They're all equivalent to each other. But for example, for 3 hours, we have 9 gallons. Now, this is one of those where there's several different ways of doing it, ladies and gentlemen. But if I stick with the same theme that I've been doing so far, well, we want to know, well, how many gallons, so we don't know the gallons, will I consume if I drive for 7 hours? Notice how I set this up. 7 hours, 3 hours, hours. We don't know the amount of gallons, but 9 gallons and gallons. Ladies and gentlemen, same as what we were doing before. Cross multiply, divide by the number next to the variable. So 9 times 7 and 3x. So 9 times 7 is 63. is equal to 3 times the variable. Divide both sides by the number next to the letter. In that case, that would be 3. That's one way of doing it, ladies and gentlemen. There's other ways. Some people have noticed the pattern that each time the relationship between hours and gallons is you're multiplying by 3. Multiply by 3, multiplying by 3. So they said, well, if you multiply 7 times 3, that would give you 21. Yes, that works, but I want to see you guys get used to writing the ratio in words, writing the ratio that is given to you, and using that to find an equivalent fraction, just like we've been doing every single day in class. All right, number 6. Again, what are the two things that we're comparing? I see that we have students and Tornado Fest games. So we have students and games. 7 students, 28 games. And the question is asking, at this same rate, how many games would 21 students play? We need to see how many games would 21 students play. Notice how I set this up, ladies and gentlemen. 2 ways of doing this. You can cross multiply and then divide by the number next to the letter. Or you can ask yourself, 7 times what is 21? And use that same scale factor to find out the answer. Either way, you would get the same answer. Number 7, 8, and 9 are all using Dr. Pepper. Dr. Pepper. So for example, remember that you can always go from a decimal to a percent or a percent to a decimal using this method. So for example, we have 45%. We want to change this to from a percent to a decimal. So meaning I'm going to move the decimal to the left 2 times. It's always 2 times. It's always 2 times. Even if it doesn't have 2 digits, it's always 2 times. Now, where's the decimal starting though? Well, the decimal, ladies and gentlemen, will always be, if you see a percent or a number without a decimal, there is a decimal there, and it's always at the very end. It's always after the last number. So the decimal is right here after the 5. So to make it into from a percent down to a decimal, I have to move it 2 times to the left, leaving me with 0.45 or 0.5, 45 hundredths. Always the exact same process. You always move it twice, ladies and gentlemen. Make sure you do the same thing for number 8. And in number 9, we're actually going from a decimal to a percent. It's the same process, just the other way around. All right, ladies and gentlemen, I'm going to leave 10, 11, and 12 for you to do on your own. This video is getting long, but notice, again, we're always writing down what are the 2 things that we're comparing, what is the ratio that is given to us, and what other information is given to us to make an equivalent ratio. Once you set it up, we cross multiply, divide by the number next to the letter, unless we can find a common number that we can multiply both the numerator and denominator by to get the answer. I hope you found this helpful, and with that in mind, I will see you next time.